today is our last day of chapter 2. We are going to do more proofs. It's basically just extra practice with this, looking at a few new theorems, practicing this a little bit more. And then don't forget that that homework assignment that you were assigned last class is for both last class and today. So it did not have to be turned in yet. It's not due till Monday. If you already did it and you're like, oh, I totally messed it up, you can always resubmit it if you want. And then on Monday, we're going to review for the test. We'll go over the assignment. You guys can ask me any questions. We'll do some other review type stuff. And then we're testing on Tuesday. As far as review materials, there is a study guide, so you'll be able to work on that if you want. It's optional, it's in your packet, and I'll have the answers posted if that's something you want to practice. But topic 2.4, geometric proofs continued. We have a few new theorems to look at. The first one is the right angles congruence theorem. And that says, if two angles are both right angles, then they are, oh, except I don't have my pen. Then they are, let me click out of this. Congruent is what we're going to say. There. Okay, then they are congruent. The reason that happens is because right angles are how many degrees? 90. And if two angles are 90 degrees, are they going to be congruent to each other? Yeah, they're going to have the same measure. They're going to be congruent. So all right angles are congruent. Congruent supplements theorem says if two angles are supplementary to the same angle, then the two angles are also congruent. So if you have two things supplementary to the same thing, they're congruent to each other. Congruent complements theorem, same idea. If two angles are complements to the same angle, then the two angles are congruent. So what does complements mean if two angles are complements of each other? Anyone remember what a complement is? Complement, it's angles that add up to be a certain amount. Anyone remember? 90, yes. It means like the same as complementary. So complementary means the angles add up to be 90. Supplementary means they add up to be 180. The vertical angle theorem says if angles are vertical, then they are congruent. Remember, our vertical angles are formed by our two intersecting lines, right? And it's the ones that are non-adjacent that would be congruent. So those two would be congruent, as well as like these ones on the other side here, these would be congruent. So those are your vertical angles. The linear pair theorem says if angles form a linear pair, then they are supplementary. The reason that happens, and actually that one we talked about last class, but remember your supplement or your linear pair looks like this. You have your adjacent angles, and on the bottom, doesn't it form a straight angle? And a straight angle is 180 degrees, so that's why that happens. A little reminder here, just like in English class, you have certain notation you're supposed to use. Like in English, you can't just put a comma wherever you want, right? So in geometry proofs, there's certain symbols you have to use in certain situations. If I was talking about angles being congruent, I need to use a congruent symbol. If I'm referring to their measures being equal, I use an equal sign and I have to put the little m. So if you're ever not sure, this is a good reminder for you. And then a couple proofs to talk about. Number one, we are given that, I have this weird symbol in here though. This weird upside down T. Does anyone remember what the upside down T means? Perpendicular, very good. You do have to know that on the test. If you're taking the test and you email me and you go, I don't know what this upside down T means, I'm gonna go, there's 1,000 places you could look for it. Okay, so the upside down T means perpendicular. So you are given that line X is perpendicular to line Y and line X is perpendicular to line Z. It wants us to prove that angle 1 is congruent to angle 2. Now, before you dive into the proof, let's talk about what we have. All right, let's kind of plan it out. Does anyone remember what perpendicular lines make? They make a special kind of angle. Ethan? They make a right angle. Good. So that means if these lines are perpendicular, angle 1 is going to be a right angle. Angle 2 is going to be a right angle. And then how many degrees are all right angles? 90. So aren't all right angles congruent? So if they're right angles, they'll be congruent. And that's basically what we're going to do in our proof. So our first step is our given. So we can put that as our first reason. And then it says angle 1 and angle 2 are blank angles. Well, we just talked about it. But angle 1 and angle 2 are what kind of angles if the lines are perpendicular? They are right. Yeah, very good. They are right angles. How did we know that? Well, remember from last time I talked a lot about context clues. Aren't we technically given a vocab word? Yeah. Perpendicular. If you're given a vocab word, use it. That's where your vocab sheet comes in handy, and you'd look and go, oh, perpendicular lines. Lines are perpendicular if and only if the lines form right angles. Perpendicular lines means you're going to have right angles. How did I know that? I read the definition of perpendicular lines. And you can write out perpendicular if you want. I just have a tendency to abbreviate. Now I know that angles 1 and 2 are right angles, therefore they're congruent. How'd I get there? Well, if you look up above, don't we have a theorem about right angles? The right angle congruence theorem. And it says if two angles are both right angles, then they are congruent. Well, did I have two right angles? Yes. So can I say they're congruent? Absolutely. By the right angle congruence theorem. Now, this is on your vocab sheet. It's on the back. But what if you're in the middle of taking a test and you're like, I know all right angles are congruent, but I can't remember the theorem. I can't find my vocab sheet. I'm doomed. I can't remember the name of it. I do also accept like an explanation as a reason. Like you don't have to necessarily write the name of it. If you know that all right angles are congruent, say that. Put that, okay? Because that would be appropriate as well. And that's it for that one. That one was really short. All right. Yeah, me too. Hopefully the ones today should hopefully make reasonable sense. So on number 2, we are given that ray BD, or DB, I'm sorry, bisects angle ADC, and angle 2 is congruent to angle 3. So here we are given a bisector. I want to prove that angle 2 is congruent to angle 3. So let's plan this out. Let's think about what we have. Does anyone know what an angle bisector does to an angle? Yep, splits it into two congruent angles. Good. So if ray BD is a bisector, which two angles do you think would be congruent? For angles, you would name them with the numbers. Yeah, angle 1 would be congruent to angle 2. Okay, but somehow we got to talk about angle 3, right? And has angle 3 is not mentioned in our given. So we're going to have to figure out a way to tie angle 3 into this proof. Does anyone notice an angle relationship that's happening with angle 3 and maybe another angle in your picture? Ethan? The line A and B are on, they're both straight. Okay, we have two intersecting lines, yeah. We do, and two intersecting lines will form what kind of angles? Yes, but they have a special relationship name. Starts with a V. Vertical. These are going to happen a lot. So they're going to happen a lot. They're going to have to be something you start to recognize. Right here with angle 1 and angle 3, we have vertical angles. And if you look up at the top of your notes, what do we know about all vertical angles? It's in your vertical angle theorem. They're congruent. So will 1 be congruent to 3? Okay. So let's think about this logically for a second. If 1 is congruent to 3 and 1 is congruent to 2, won't all 3 of them have to be congruent? Yes. So now we just got to write that down. So first, let's put in our given. Ray DB bisects angle ADC. That is given. And we want to prove that angle ADC. Sorry, I know it's kind of sloppy. It's just the given. And then we want to prove angle 2 is congruent to angle 3. Okay, remember, use your context clues. We're given a vocab word. We are told that we have a bisector. So if you're like, I don't know what that does, what should you look at? Your note sheet, your vocab sheet. You'd go to your vocab sheet and you'd go an angle bisector. A ray is an angle bisector if and only if it divides an angle into 2 congruent angles. So if you have an angle bisector, we can say we have 2 congruent angles. 1 and 2. Sorry, I'm choking. Can't talk. Issues with my vocal cords. Like when I talk loud, they're like spasming, and then I like can't talk. So that's what keeps happening to me. It's driving me nuts. Oh, it's been like for a while. It's kind of terrible. Because I'll just like stop being able to talk. And there's nothing I can do about it. So sorry, guys. Oh, it's very unpleasant. Okay. And it's just not an ideal time in the world to have to cough. But it's like, because my like vocal cords, like, I don't know how to explain it. They like spasm and then I can't speak. And it's kind of terrible. All right. I'm back though. All right, sorry guys. We're back. I'm functioning again. We're good. All right, so what I was trying to say was that angle 1 is congruent to angle 2. All right. And that is because they are, we have our bisector. So definition of an angle bisector. All right, and then when we were planning our proof, we talked about how we need to get angle 3 in there, right? And angle 3 is a vertical angle with angle 1. So what we're going to do is we're going to state that those are vertical angles. So angle 1 and angle 3 are vertical angles. And we know that because it's not like told to us, but can we see it in our picture? Yeah. So if you notice our angle relationship in your picture, you can use it. And you would say, given by picture. All right. Then, if you look up at your new theorems, do we have a theorem about vertical angles? Yeah, and it says if angles are vertical, then they are congruent. So angle 1 is congruent to angle 3. That's the vertical angle theorem. And if you ever can't remember that, guys, a good way to put this, you know, like how I said that all right angles are congruent, you can kind of do the same thing with vertical angles, and you could always simply say vertical angles are congruent if you want. But it is also the vertical angle theorem. So either way you want to state that. And then last thing, if you take a look here, if you look at this line and this line, what do you notice about angle 2 and angle 3? What are they both? They're both congruent to angle 1. And if they're both congruent to angle 1, will they be congruent to each other?
Yes.
Yes. And this is actually a property we're going to use a lot, and that is the transitive property. When two things are congruent to the same thing, we can say they're congruent to each other. Maybe one day I'll be able to talk normally again. You could just hear it. My vocal cord just went, I couldn't talk. Oh, okay. Next, how many more of these do we have? Okay, we have a couple. We'll probably do, let's look at number 3, and then we'll take a little break. Let my voice come back for a second. All right, so number 3 on the back, we are given that line L bisects segment AB at M. We want to prove that segment AM is congruent to segment MB, so this is a nice short one. You good over there, Trey? You lost? No, just looking. Okay, just looking through it. Oh, okay. No, you're fine. Okay. No, you're fine. I just you looked like you were looking for your place in there. Okay, so we're gonna say here that line L bisects segment AB at M, that is given, and then segment AM is congruent to segment MB. Okay. So this one's a little trickier because this is a segment bisector. So if you look at your definition sheet and you go to segment bisector, it says a point, line, plane, or ray is a segment bisector if and only if it goes through the midpoint of a segment. So what's different about this is when you had an angle bisector, didn't it split your angle into 2 congruent parts?
Yes.
But if you have a segment bisector, it doesn't do that. It goes through the midpoint. And then the midpoint is what splits it into 2 congruent parts. So this is why using your vocab sheet is going to be really handy. So since you have a segment bisector you're going to use your definition of a segment bisector, and you're going to say that you have a midpoint. Which point would have to be the midpoint? M. So we're going to say M is the midpoint of segment AB. That is so we had a bisector. And so that is the definition of a segment bisector. Good. And now we have a new vocab word, which is midpoint. And if you go again to your vocab sheet, go to midpoint, it says a point is a midpoint if and only if it divides a segment into two congruent segments. Okay. Weird. Okay. So if you have a midpoint, if you look at your definition, do you have two congruent segments? Yeah. So that was by the definition of a midpoint. Good. And proof for problem 2, which we have not done yet. This is our first paragraph proof. What a paragraph proof is it's the exact same thing as your 2-column, except instead of that chart structure, it's just in sentences. That's really the only difference, okay? So what we're going to do, so it says write a paragraph proof for problem 2. This will be the exact same proof, just written as sentences, not in columns. So first thing is still always, no matter what format you're writing it in, the first thing is still going to be your given, okay? So that means, what do you think we'd put in this first blank here? If it's line blank, bisects blank at blank. Yep, line L bisects segment AB at M. By the definition of blank, point M is the blank of AB. Well, we decided in our previous proof that M was the what? Midpoint. So that would mean by the definition of, oh yeah, thank you. I'm like on my next line already. By the definition of a segment bisector, because that was our previous vocab word, point M is the midpoint. Of segment AB. And if you just put bisector, that's okay. So then by the definition of blank, well, what was our new vocab word in the last sentence? Midpoint, right? We can say that segment AM is congruent to segment MB. So it's the same thing, just written as sentences. All right. 2 more. 3 more? Oh, well, one of them, it's like the same thing. We're going to write it as a paragraph, then as 2 columns. You good over there, Al? Okay. All right, so number 5, we are given that angle 1 and angle 4 form a linear pair, and that the measure of angle 1 plus the measure of angle 3 equals 180. We want to prove that 3 is congruent to 4. So let's look at what we're told. We are told that these form a linear pair, which, remember, your linear pair, they're adjacent, and they're going to form a straight angle on the bottom. You're told that 1 and 3 add to be 180, and we want to prove that 3 and 4 are congruent. Now, why would maybe having a linear pair be important? Well, linear pairs are always what? Who remembers? They're always supplementary. Good. Linear pairs are always supplementary. And then don't we have another set of angles that's technically supplementary since they add up to be 180? Yeah. So if you go up to one of your previous theorems that we talked about today, If two angles are supplementary to the same angle, they end up being congruent. So that's kind of how we're going to prove this. So first thing is our given. Go ahead and fill that in. Angle 1 and angle 4 form a linear pair. Then it tells me to apply the linear pair theorem. And maybe you're in the middle of a test and you're like, I don't remember what the linear pair theorem says. What should you do in that situation? Where should you look? Your vocab sheet. And it says, if two angles form a linear pair, then the angles are supplementary. Oh, I forgot I didn't fit my other given in. We'll also add that in. Measure of angle 1 plus the measure of angle 3 equals 180. Okay, there's my other one. So the linear pair theorem tells me if two angles form a linear pair, then they're supplementary. Do I have two angles that form a linear pair? From my given, do I have that? Am I told that? Yes. So can I say that they're supplementary? Yes. So I'm going to say angle 1, or the measure of angle 1 plus the measure of, or no, I'm sorry, we'll do that in the next step, my bad. I got ahead of myself. We just simply now want to say that they're supplementary. Angle 1 and angle 4 are supplementary. Okay. Now it's telling me to apply the definition of supplementary angles. Anyone know what that is? What the definition of supplementary angles would tell you? And we shouldn't have to guess because everyone has a vocab sheet. Good, yes, thank you, Gannon. They are going to add to be 180. So we're going to say that next. The measure of angle 1 plus the measure of angle 4 equals 180. Good. Now it's telling me to use substitution or transitive. Now something that I'm pretty sure I mentioned to this class is anytime you have two equations and they equal the same thing, it's never a coincidence. I think I mentioned that, but I'm not sure. And if you take a look at your given, don't we have an equation that adds to be 180? And then doesn't this equation add to be 180? Never a coincidence. If they add to be the same thing, then what it wants you to do next is set them equal to each other because they both equal 180. Does that kind of make sense? Yeah. Because they both equal 180? Right, okay. So we're going to say that the measure of angle 1 plus the measure of angle 4 equals the measure of angle 1 plus the measure of angle 3. And we did that. Either substitution or transitive works. You can think of it with substitution because it's like you're taking this value and plugging it in for 180. Or you can think of it as transitive because they both equal 180, so they're equal each other. Either way. Now it's telling us to use the subtraction property. Why might that be a hint that we're given? How could we maybe apply that? Think about where we want to end. Don't we want to end with, yeah, we want to end with angle 3 being congruent to angle 4. So how could I maybe, what do I need to get rid of? Yeah, we need to get rid of the 1. And technically, if you guys look at this, technically, do I have this written in the correct order for it to end up with a 3 and then a 4? When I have a 4 and then a 3? Technically, if you notice that, no, it doesn't matter that much, especially like for my GT class, I'd be like, yeah, that's wrong. But like for you guys, I'm not that worried about it, but you can always just take it and switch it. That's not hard to do, you know? I'm not that picky about it. But here we can subtract it out. So we're gonna subtract it out from either side. And the measure of angle 3 would equal the measure of angle 4. Because we subtracted out the 1. And then, are we allowed to say if their measures are equal, then they're congruent? Yes, by the definition of congruence. Thank you. And after we haven't had like normal class in a while, it's hard to go back to like normal class. All right, number 6, we are given that angle 2 is congruent to angle 3 and we want to prove angle 1 is congruent to angle 4. Complete the following paragraph proof. So if you take a look, we're given that 2 is congruent to 3. We want to prove that 1 is congruent to 4. Now, before we dive into a look at your picture, we talked about this kind of angle towards the start of class. Who can remind me when we have our intersecting lines like that, our X shape, what kind of angle relationship does that make? Very good. Vertical angles. And vertical angles are always what? Congruent. Very good. These are all things that you're going to have to start to like think about and recognize because they're going to come up again and again. So technically, won't 1 and 2 be vertical? So aren't they congruent? Won't 3 and 4 be vertical? So aren't they congruent? And it also told me 2 and 3 are congruent, right? Right. Yeah. So, well, and those were given. So everybody's going to be congruent. So that's how we're going to work this out. So we're going to show our vertical angles are congruent, and therefore 1 and 4 will also have to be congruent. So this is kind of like a big transitive property thing. These are congruent, so these are also congruent. So we are given that blank. Put in your given. That is that angle 2 is congruent to angle 3. Angle 1 and angle 2 are what kind of angles? Vertical. Good. Are vertical angles, and blank are vertical angles. 3 and 4. And if you notice, guys, use your context clues. If you had just finished reading that sentence, would you probably have been able to figure out what kind of angles they were, even if you weren't totally confident? Yeah. Then by the blank theorem, we can say that angle 1 is congruent to angle blank. Well, didn't we just say they were vertical? And vertical angles are always congruent. So angle 1 is going to be congruent to angle 2, but then the question is, what theorem is that? Vertical angles. Aren't they vertical angles? Vertical angle theorem. Don't overthink it. If you overthink it, you're probably going to get it wrong. So vertical angle theorem. And what else would that work with? 3 and 4. Good. Then by the blank property, angle 1 or angle blank and angle blank are congruent. Well, don't we know what we're supposed to end with? 1 and 4, right? So you can go ahead and put that in. But what property is this? Well, we have that 1 and 2 were congruent. Wait, did I write something wrong? Nope, I didn't. We had that 1 and 2 were congruent, didn't we? But if you look at your given, wasn't angle 2 congruent to angle 3? Yeah. Well, yeah, so, and then over here, we had that, sorry, I'm highlighting the wrong things here. Let me fix this. Okay. We're trying to prove 1 and 4. Okay, sorry, I highlighted the wrong one and I confused myself. So if you look here, we have that 1 and 2 were congruent and 3 and 4 were congruent, right? But we wanted to show just that 1 and 4 are congruent, right? If you look up at your given though, didn't we have that 2 and 3 were congruent? And if 2 and 3 are congruent, won't then 1 and 4 have to be congruent as well? Yes, that is the transitive property. Yeah.
It's like at the very end, like the last, almost, yeah, like the last property. With things like that, I get confused with the subtraction. Substitution.
Yeah. So, well, substitution and transitive are very often, you can interchange one for the other. Typically, though, if you see congruent signs, it's transitive. Right. And this one you could have used either because it was an equal sign. This one, technically it's a congruent sign, so you would use transitive. However, if you were doing like a fill in the blank one and you gave me substitution, that still tells me that you know what's happening, you know, and I'd probably give it to you. But if it was like a drop down box, something, I'd probably only, like, I wouldn't put both substitution and transitive to throw you off. All right, so we're gonna take this and turn it into a 2-column proof, and then we're done. Except one of my lines went down, so that's okay. So first thing is always your what? This is a freebie. First thing's always your given. So angle 2 is congruent to angle 3. Is your given. And then think about where our paragraph proof led us. As shown by the picture, angles 1 and 2 are vertical and 3 and 4 are vertical. So that's what we're gonna say next. Angle 1 and angle 2. And then I'm just gonna put a comma so I can list both. And angle 3 and angle 4 are vertical. And I knew that because that is given in the picture. And then what do we know about all vertical angles? They are congruent. My V in vertical looks more like an N. We'll fix that. Okay, they are congruent. So I can say angle 1 is congruent to angle 2, and I can say angle 3 is congruent to angle 4 by the vertical angle theorem. A little pro tip for you guys, we almost never use the definition of vertical angles. If you're using vertical angles, it's probably the theorem. And what can you do if you can't remember the name of it? You could describe it. I would accept that as well. Okay, good. And then we actually have extra lines that we don't really need, because in your given, we were told that 2 and 3 are congruent, right? And if 2 is congruent to 3, what can we say about 1 and 4? 1 and 4 are congruent, good. And that is the transitive property.